Andrew Magill with Geoweaver as a gateway to manage distributed geoscientific workflows.
Hi, thank you, Claire. So I'm Andrew Magill. I'm a developer at the Texas Advanced Computing Center and at SGCI. Today, I want to present to you Geoweaver, which is a project that I worked on through an EDS engagement with SGCI and Dr. Jensen Sun at George Mason University. So I'm going to talk about what Geoweaver is, how it works, what makes it special, our future plans, and hopefully take some questions here. So what is Geoweaver? Geoweaver is a web platform that enables you to manage deep learning workflows with provenance across distributed resources. We've geared it towards Earth scientists, although I think it could be useful for many people. But we hope that it helps Earth scientists manage these large amounts of data that they have to process over often many different systems. So how does it work? Let me go back to this slide just for a second. As you can see here, we have different types of things here. We have hosts and processes and workflows. So let's talk about how those work together. So we can register different types of hosts. Here we're going to register just a regular server that we're going to connect to through SSH. We can use this to store files or run execution processes. Here we're putting in the IP address and some authentication information. And we'll see now how we can take a look at this. We can, right now, we can just view files on this system, which we'll do here. This is a video, obviously, and this is not live. There's our file listing. Okay. We can also add Jupyter servers as hosts to participate in our workflows. So here we're going to add Jupyter Notebook host, calling it Jupyter VM. We give it the URL and port. And we're going to connect to it really quickly. Don't have any notebooks yet, but here you see that we've connected to it. And we actually proxy the WebSocket traffic through Geoweaver, and I'll show you a little bit later why that's kind of neat. So we have different types of processes that we can run on our host. Here, we're going to add a bash script. This script is just going to download some imagery to process later in our workflow. Give it a name here. We have this little editor here where we could type it in or modify it. We're actually going to run it on that VM that we added earlier. I won't run the whole thing, but you can see it get started. Just put in our passwords again. Like Rajesh said, we don't want to store that. And so we can see the log in real time here in our console. We can go over to the process, say, look at the history, see that it's running. We can actually stop it if we want here, which we won't. We'll just let it continue to run. Go back to our console and see how that progresses a little bit. And see there, it's connected and starting to download the archive. Okay. And we can upload or import Jupyter notebooks. Here I'm going to upload one notebook. I'll just say a word about this notebook. I have an undergraduate degree in geography, but I don't do a whole lot of it. Dr. Sun works in the Geoscience Center at GMU. So that's kind of his focus. I went to this tutorial at University of Colorado to find these really neat notebooks that kind of teach you data science with geospatial processing, and I recommend them to anyone who's I'm sure all you are very familiar with it. Anyone who wants to give a tutorial to somebody to learn more. It's really neat. And then we can take a look at the history of that process that we ran earlier to download the imagery. We can get a full listing of the output, full log history here. And Geoweaver records everything that we do. So it's going to know all the processes we run. It's going to know all the output, when we run it, what the results were, if there were any. We can download results. And then we can go to our VM and take a look at the imagery that was downloaded and unarchived here in the imagery folder. And we can even download from our remote server if we want. I think we do here. And then it's important, I want to show you that we can link these processes together in workflows so that we can have independent processes working in parallel independently on different resources, and then we can link them together sequentially here so that one process is triggered when another one finishes. And here we'll just save this workflow. So I imagine a lot of this is very similar to what all of us are doing to kind of make our lives easier, but I wanted to talk about something that I think might make Geoweaver unique, that feature of proxying the WebSocket traffic through the server allows us to store versions of our notebooks as we work on them. So here I'm just going to make a very simple change. I'm going to change the path to that imagery, and I'm going to save it. And Geoweaver listens for that save command. Now, it could listen for other things. It could listen just for us to execute a cell. At the moment, we're just listening to the save, and it makes a separate version of that Jupyter notebook that we can go back and look at. We can download. It helps us to retain provenance of our workflows. This is a new feature that we're really proud of. Here we're going to look at the history. And we can see two versions. We can view our previous version, which was the one I uploaded. And then let's take a look at the new version. Here we have some changes to the file path there, the imagery folder. And then if we want, we can download the original version. Okay. So future work, this is very much in development. Dr. Sun just was awarded a grant from NASA to continue development on this. I think that a major goal for our next feature is incorporating support for Google Earth Engine, which is something that we're currently working on. There are a lot more things to come also. I'd be interested in hearing your feedback. So acknowledgements here. This project has been supported and funded by ESIP-Fed, SGCI, and NASA very recently. And the following people have contributed: Dr. Sun, myself, Liping D, Annie Burgess, and Jason Tullis. So I'd like to, here's our contact information. I'd like to take any questions that you might have.
Okay, perfect. Thank you very much, Andrew. And I think our first question actually was the tutorials that you mentioned earlier in your presentation from Rebecca.
Okay. Sorry, let me look at the chat. I'm kind of lost. Where's the chat? Okay, chat. Oh, yes. What was the name of the tutorials? Let me go back to that slide I have written down, but it's probably easiest if I go back to the slide here. It was, yes, this one here. Okay. I think I can just probably follow this link. The tutorial is, it's kind of an online textbook, intermediate Earth data science textbook. Let's just follow it. So it's all right here, and they have just tons of tutorials. doing really all kinds of things. Look at the chapters here. So if you go to earthdatascience.org, you can find it. Also, my slides are right here at my name, andrewmagill.github.io, and I will upload a PDF version of this so you can hopefully follow the links. But let me go back to this right here, earthdatascience.org. Really nice.
Excellent. And thank you for sharing that resource. Rajesh has also a question for you.
Okay.
Do you use an existing workflow engine to manage data staging and workflow planning?
No, we're not actually. It's all done through SSH, and we're using libraries for that, but we don't kind of have like a framework that we're using right now. This is all Java on the back end and Spring Web Framework, JavaScript on the front end. It's pretty low on libraries and frameworks, but I'd be interested if you have some that you've looked at. Do you have any thoughts on that?
And Rajesh, you're welcome to unmute if you'd like to follow up that question.
Yeah, that was going to be a lot easier than typing it. Yeah, we looked at several workflow frameworks. We looked at Airflow, Luigi,
Oh, right.
a couple of the more popular Apache-based ones. But then we settled on Pegasus just because it does a whole lot of the data staging behind the scenes for you pretty seamlessly, so you don't have to really worry about where your data is going and how it gets staged to your compute servers. And it also brings the data back for you. And of course, it also supports like containers and all kinds of different environments. And so that was really the best of all worlds for us.
Very nice. Thank you.
Great. Yeah, and we have one more question. Looks like, yes, one from Junhan. So do you use a cloud platform for the back end? And I think there was also maybe another specific thought there about the hosting.
Right. So this is hosted on the web. It's still early days in development, so I think it's probably most useful installing locally if you want to use it at this point. And there are some features that are finished, but we're still working on it. But it is deployed just like a traditional web application. It's not. It doesn't kind of use any kind of cloud features for deployment and hosting. However, we do want to incorporate support for compute in the cloud, right? So that's where Google Earth Engine comes in. I think that's really big. I'm not sure if that answers the question. Sorry,
yep, looks like it did. Great.
Okay.
Maybe we have time for one more question if someone has a thought they want to ask.
Yeah, I'm just going to unmute and ask, sorry.
Yeah,
So
no.
Andrew, so you mentioned Google Earth Engine. So I thought Earth Engine requires you to use Colab or one of those Jupyter frameworks to get access to their data sets, right? So I thought let me rephrase that. I thought you can't use Google Earth Engine to just get the data from this. Are you thinking of getting the data from Earth Engine or using the compute? Because I thought if you had to use the compute, you'd have to use their own platform to do that, and you couldn't use your own Jupyter notebooks.
Well, that's a good question. I don't know the answer for it. I haven't worked on that feature yet. Dr. Sun, I believe, is here, and I think he's been working on it. I'm not sure if that's something that he wants to speak to at the moment. Yeah, unfortunately, I haven't touched it yet, so it's not a feature that I've worked on. But that is a good question. I don't know if.
Yeah, that might just be because that was like a year or two when we were looking at the different satellite data resources that they had posted on there, and it seemed like you had to actually use their UI and their sort of IDE to get at those resources. So yeah, but that might have changed now.
I will get back to you on that.
Sure.
Thank you. Thanks.
All right, fantastic. Well, let's head on to our final presentation for today. We will be hearing from Jared McLean, and I should also start by saying thank you very much, Andrew. A great presentation. Really appreciate it.
Thank you much.